To enable both cloud architecture offerings and the ability to deliver these solutions globally, Microsoft is investing heavily in data centers worldwide. Construction of new facilities ran through 2008 and continues through 2009, with projections of over 20 Tier 1 carrier-class data centers around the world. These data centers are built with industry best practices, offering some of the highest green ratings and capacity per square foot numbers, resulting in highly competitive pricing models. Windows Azure is the next generation cloud operating system. It runs on top of the global foundation services that combine the networks, facilities, and power assets. Windows Azure is a global fabric of compute, storage, and management capabilities. It is a runtime platform for the development of services. The platform abstracts the client from the infrastructure, scaling, fault tolerance, and disaster recovery aspects of the solution. The compute capabilities of Windows Azure allows for developers to build components in Visual Studio and deploy them to the cloud. Today, Azure supports two types of components. The first is the traditional ASP.NET components deployed as a web role. The second, non-visual.NET components deployed as a worker role. Every component is deployed and hosted in its own virtual machine and can scale independently. These components can use the Windows Communication Foundation to call RESTful interfaces of other Microsoft, third-party, or their own enterprise services. Windows Azure supports deployment across geographic locations. It can support an edge-based deployment model, where it dynamically can move components of a solution between data centers, bringing them closer to the physical markets they are supporting. Configuration by the client can specify which components should be deployed together in physical data centers for best performance. Configuration by the client can set up geofencing of components to control where they are allowed to locate. This can be critical in supporting security concerns, international laws, or disaster recovery strategies. Azure Storage provides basic storage capabilities directly in the platform fabric. This includes blobs for large-scale unstructured storage, hierarchical tables for name-value pairs, and queues for message-based communication. These are basic storage services to support the application components and session state. They can also support basic application data, but higher-level data storage services will be introduced later in the presentation. Azure Developer Services are building block services that Microsoft has developed for the enterprise to use in constructing solutions on Windows Azure. These services span technical aspects of security, integration, and storage, in addition to business services like capabilities arising from Microsoft Advertising Platform. Microsoft will continue to expand this layer beyond the initial offerings displayed here. This layer is also open to third-party software community to expand, as well as the enterprise that may build their own private or public building block services for their business or industry. Live services are building blocks around rich, interactive, multimedia experiences and social networking. Data synchronization services, called Live Mesh, can synchronize data across devices. Each of these major groups has numerous components that can be composed and combined as part of your development. Live Services has been around for several years and has helped enterprises rapidly add functionality and value to existing solutions. SQL Services is a higher-level data storage service. It supports basic storage capabilities similar to what was described in Windows Azure Storage. SQL Services is evolving to support a full relational database capability, reporting, and business intelligence services at a global scale. There is an important distinction between Azure Storage and SQL Services. Both can be used independent of one another. Azure Storage may be used for a different class of information, for example, application configuration or session state. At the same time, SQL Services may be storing actual business and transactional data. They both exist separately and can be configured separately to support different needs and rules around geographic deployment, security, and disaster recovery needs. Hybrid solutions of cloud and on-premise could combine local SQL Server and cloud-based SQL services. SQL Services could be used for a range of options, including serving as a system of record, a data mart for staged data, or opera marts for transactional data. Lastly, they could even be deployed for data warehousing. An enterprise could also build Azure Worker Role components to access the data or perform batch functions to move data back and forth from the cloud to the enterprise. .NET services are major building blocks around security, workflow, and integration. Access control is a service that allows cloud-based components to access security and identity sources back in the enterprise. This method would allow an enterprise to put a service in the cloud that would call back to their Active Directory infrastructure through the access control service. Access control is one component of a larger security service framework called Geneva. This framework and infrastructure allows for the construction of federated, claims-based security models. It would allow for an enterprise and vendors to create their own identity services for their private or public use. Complex business process scenarios can be supported through that flow through a variety of client, vendor, and third-party solutions while maintaining a federated security model. Workflow provides .NET Workflow Foundation capabilities in the cloud and can be used to integrate workflows between cloud services and the enterprise. Service Bus is a full enterprise service bus for global business. It can serve integration needs between services and the enterprise, or between B2B partners. CRM and SharePoint services are building blocks to extend the MS Online CRM and SharePoint services. They allow enterprises to extend the cloud solutions of these products and customize their own implementations for private or public use. Third-party software vendors can use these building blocks to create their own branded implementations to resell as services. The Global Foundation Services, Windows Azure Operating System, and the Azure Developer Services together form the Microsoft Azure Services Platform. This is a platform as a service offering to allow Microsoft, third parties, and enterprises to build their own services and deploy them in the cloud, abstracted from the concerns of infrastructure, scale, and platform upgrades. Microsoft views the flexibility of combining both the full enterprise platform and the global cloud platform as a strategic advantage for enterprises. They are intended to work and integrate with each other. Both will continue to evolve together to increase this synergy. The development and system management toolsets are also evolving to integrate both platforms together and give users a seamless experience in building, deploying, and managing assets. Both platforms are designed for enterprise-class solutions. The level of investment will be unequaled throughout the industry. Microsoft has been in the enterprise platform business and understands the requirements required in building a cloud platform and integrating it with the enterprise. The technologies, languages, and tool sets for Azure are the same as in the Microsoft Enterprise Platform. This will enable all .NET developers to rapidly leverage the capabilities and value in the cloud platform. The software development and application lifecycle development tools are equally integrated to the cloud platform to help manage full lifecycle development efforts from requirements, development, testing, and deployment.